And speed.
Hi, I'm Steven. You're watching Steven Loves Science, and today we're going to talk about the four main types of chemical reactions. Now, the four main types of chemical reactions are direct combination, decomposition, single replacement, and double replacement or displacement reactions. So we're starting with direct combination, which basically says you can add two separate elements to yield one new compound. So here are our reactants side of the equation, and here is our product side. So in this conceptual representation of the direct combination reaction, you have A plus B yields AB. So I hope you all know how to write molecular formulas because I am not including that. But in this reaction, we have sodium, which can be represented as Na, is the atomic symbol, plus chlorine. Now, writing this reaction, we're going to write Cl2 because in nature, chlorine always occurs in diatomic form. So before we move on to find out what our products are, when you look on the periodic table, you see a valence number or oxidation number. Now, in the case of sodium, the oxidation number is 1 plus, and in chlorine, it is 1 minus. So when we add these, the oxidation numbers are going to trade places and switch across. So we're going to move over to this side. We're going to add sodium and chlorine. Whenever you have a reaction, you're going to drop the subscript of your element or polyatomic ion. The subscript is not going to be carried along because we're going to get a new subscript when we carry over the 1. So that means we get NaCl. But this is not correct because according to the laws of conservation of matter and energy, matter cannot be created or destroyed. And what we just did here was we just destroyed 1 atom of chlorine. But we can fix it by balancing the equation. Now, to balance an equation, you add coefficients in front of your elements or molecule or compound. So we see that we have 1 sodium on this side and 1 sodium on this side, so that's balanced. We have 2 chlorines on this side, but we only have 1 chlorine here. Now, in order to fix that, we put the coefficient of 2 in front, and the coefficient 2 multiplies everything here, just like it does in math. So that means we have 2 sodiums and 2 chlorine. But now we have 2 sodiums. So in order to correct that, we put a coefficient of 2 in front of the sodium. And that is a correctly balanced equation. Okay, moving on to the second type of chemical equation is a decomposition reaction. Now, in a decomposition reaction, a compound will decompose into its 2 respective elements. In this case, we have dihydrogen monoxide, which is water, so H2O, is going to decompose and come apart to hydrogen and oxygen. Now remember, oxygen is also diatomic, so oxygen will be having a subscript of 2 here. So now this is also unbalanced because we have 2 hydrogens, but we only have 1 oxygen on this side. So in order to correct that, we're going to put a 2 here. So we have 2 oxygens. But now we have 4 hydrogens on this side, but only 2 hydrogens here. So we're going to correct that by putting a coefficient of 2 in front of the hydrogen. And now we have a correctly balanced equation. Okay, now we're moving on to single replacement reactions. Now in a single replacement reaction, a more reactive metal will replace a metal that's already in an ionic compound with a nonmetal. So in this case, metal C, is going to boot out metal A from compound AB and bond with the nonmetal B. So then we get Cb plus A. And the A is going to come out as a precipitate, but we're not getting to precipitates yet. So let's take this example. Let's consider this example. Silver nitrate, which is AgNO3, is going to react with copper. Now, although this does not have a charge, it technically has a charge of 0 at this point, because all elements have a charge of 0. We're just going to put its oxidation number to make it easier to understand what's going on. That's not technically correct, but we're just going to put it there. And silver is +1, and our polyatomic ion nitrate is -1. So copper is a more reactive metal than silver, so copper is going to displace or replace silver from silver nitrate to give us copper nitrate. And silver metal is going to come out. But this is not correct. Remember that copper has a charge of +2, and this only has a charge of -1. But the net charge is going to have to be 0. So in order to do that, we're going to put a 2 here. Now this is -2, this is +2, it equals 0, and it's happy. And our silver has come out. Now if you do this, it's very cool, and silver, you'll see little crystals of silver coming out of solution. It's very cool. Now let's check to see if this is balanced. We have 1 silver here, 1 silver here, 1 nitrate, but we have 2 nitrates now. So we're going to put a 2 here. So now we have 2 silvers. So we're going to put a 2 here to say that we have 2 silvers. So now we have 2 nitrates, 2 silvers, and 1 copper, and that is balanced. Okay? Okay. Damn.
Oh. Indeed.
Okay, so now we're going to consider double replacement or double displacement reactions. Now, a lot of people seem to be confused by it, even though it's really not that confusing. So let's consider the conceptual double replacement before we move on to actually doing a reaction. We have compound AB is reacting with compound CD. Now in this reaction, the nonmetal from CD is going to replace the nonmetal from AB, and the nonmetal from AB, which is B, is going to replace D. So basically, just think about it as the 2 metals are switching partners and they're trading nonmetals. So now let's consider the reaction of calcium chloride and silver nitrate. Now, before we go ahead and start writing, let's just say, well, what would happen? What's the nonmetal here is our nitrate group, and the nonmetal here is chloride. So they're going to switch, and what we're going to get is calcium nitrate and silver chloride. So let's go ahead and write a reaction. Before we do so, we're going to write the oxidation numbers above to help us better understand what's going on. And then our nitrate is 1 minus. So, they're going to switch partners, and the charges, the subscripts, are going to drop. So our chloride subscript is going to go away. The only subscript that's not going to change is our nitrate, is the O3, because it's a polyatomic ion, and it's the only subscript that did not change. So what we're going to get is calcium, NO3, 2. The reason it's NO3, 2 is because we're going to want our new compound to have a charge of 0, but calcium has a charge of 2 plus, but nitrate only has a charge of 1 minus. So in order to get it to equal 0, we're going to need 2 1 minuses to get to 2 minus, so it cancels out with the 2 plus. And the other thing we're going to get is silver chloride, and the 2 has dropped because we only need 1 chloride to cancel out the positive charge of the silver. But we're not done yet because it still has not been balanced. So balancing this equation, we would say there are one calcium here, one calcium here, two chlorides here, only one chloride here. So we're going to put a 2 in front of here. And there's one silver here, but 2 silvers here. So I'm going to put 2 silver here. And there are 2 nitrates here, because remember the 2 will distribute into both of them. And there are 2 nitrates here. And that is a completed balanced equation. I hope this video has helped you, as this is only our second video. We hope to have them improving time after time, so your comments, suggestions, and feedback would be appreciated. Thank you, and thanks for watching.